Taboola is a discovery platform, giving people the moment of next. I'm Bentzi, working 7 years at Taboola. I'm Data Labs team lead, working very closely with R&D, Vertica R&D, and professional services. And of course, as you can see, I'm on my free time, I'm a bicycle freak, and as I love extreme sport, we at Taboola love to take Taboola to the extreme, and I will show that to you. So, this is better. So, Taboola service 1.5 billion unique users per month. We are analyzing 3 billion page views a day. We are getting 1.5 million HTTP requests per second, which translate to 500K recommendations requests per second. In total, we are collecting and aggregating around 100 terabytes a new data per day. Taboola main infrastructure is on-prem with more than 10,000 physical servers. I think now we are close to 11,000. You know, the world is missing servers. We are server as well. We have 7 regional data centers globally, service the recommendations. So Taboola widget is embedded into our customer websites and mobile devices. So basically every one of you sees us every day. And we like it. We have 3 backend data centers, all located in Israel. We have a wide stack of technologies to handle and process the data, one of which is Vertica, and we are glad about it. So, how Vertica looks in Taboola. So we have 5 backend clusters, 4 enterprise mode and 1 migrated to Eon on HDFS. We have 3 front-end clusters serving the dashboards and the end user and customers of us. And of course, REST API calls, many of them are coming in. In total, we are managing 180 Vertica servers. We do parallel raw data ingest, parallel ETL for multiple data sources, and we'll see soon. And we have various utilities to maintain consistency. Here you can see the many data sources coming into Vertica, and for monitoring, our stack contains Prometheus with Grafana, Sensor, and along with many in-house developments, all to maintain consistency and clusters health. Focusing on Eon, we have strong servers, you can see. We are running at the moment 40 servers with 40 shards, 1-to-1 ratio. To be changed soon, we are participating in beta testing of the new reshard feature from Vertica. About Eon scale at the moment, 1 cluster of course. So basically we have high concurrency, both for loads and for aggregations, with 600 terabytes of HDFS cluster. You can see here the messy and complex environment we developed over the 7 years with Vertica, the backend and the front end and the mesh of all the raw data and aggregations and analytics, and of course the front end. This is how to maintain, how to scale, and we don't want to stay in this environment. What we want to achieve with Vertica is having a primary subcluster for data ingest having subclusters for data processing, and having multiple secondary subclusters running on Kubernetes for analytics, and of course for any internal applications like the BI and Taboola and all the analysts that we have, the groups, and many of them, and of course, and it's very important, something that we don't have today, QA. For the QA team to have a dedicated subcluster for real with all the data to ingest and not sample of the data. This is very important and something we don't have today on enterprise. In the following minutes, I will discuss about the project milestones, challenges, and how we overcame them. First question you can ask is, you have your ecosystem running, you have utilities and synchronization to maintain consistency, why you need Eon? So first, as we saw before, compute and storage separation will give us easy scale out, of course, will easy to maintain, and reduce the complexity. And of course, we talked about workload isolation, and today we're doing it with resource pools. It's not enough. Real workload isolation, this is the main key. Why HDFS? People are using S3, but we are on-prem. At the time, only MinIO and Pure Storage are available on-prem, but we Taboola are using in production big Hadoop clusters. So we have the knowledge and experience to manage them and to tune them for max performance. It felt natural to ask Vertica to support HDFS. Vertica 10.0 delivery HDFS support for communal storage. We can start, that's great, but a major blocker we found that basically Eon on HDFS required HDFS truncate operation. Unsupported in Cloudera 2.6 that we were running at the time, challenge accepted. We start to plan our, not only the upgrade to HDFS version 3, but also migrating from Cloudera to native Hadoop. This actually took us a whole year, and we'll see later why. But we are not waiting, we are progressing, we want to run fast. So we deploy our small test cluster with HDFS version 3. We learn Eon, what it brings, what metrics we need to add, and we add them to both to the Prometheus as metrics and dashboard on Grafana. We are not using the management console, so we just bring them in. We observe immediately two issues. When you want to migrate the cluster, you have two options basically. You can create a new empty cluster on Eon Mode and migrate the data by yourself. This is a complex and not easy migration that you don't want to go into. And Vertica provides the building function to migrate enterprise to Eon. But because it's a new feature on HDFS, we found some issues. Of course, we observed some query performance degradation in version 10. Both issues were fixed after a few minor versions, and we can proceed. As the paper that saw the Kubernetes session, we love that, and we have a huge Kubernetes cluster in Taboola, contains 1,000 physical servers, and we want to use them for Vertica as well. Not the algorithm team only, we want to be participate in that. So we play at the time with the beta version of the Docker image, and it was great. And I'm glad to have a pioneer together with Vertica to support the hybrid mode, meaning your primary cluster is outside Kubernetes And subclusters are inside. At the beginning, the plan was to be all outside or all inside. We said, why? It's working for us, learn and let's deploy. And Vertica done it, and thank you for that. June last year, we finally bring our HDFS, native HDFS version 3 cluster in production. This was a huge project for us. Our data infrastructure team needs to build the entire Puppet manifest from scratch, also developing the entire automation to maintain a Hadoop cluster, meaning add and remove node, put node in maintenance mode, rolling upgrade, rolling restarts, and of course name node failover. This is a huge project, and Oleg, also here in the crowd, participate in this project. If you are interested about it, ask us later about it. On July, we migrate the first backend enterprise cluster. Yeah, we sacrifice cluster for that, but it worked. So when you migrate using the Vertica function, you repeat the function one other time until the Eon cluster is consistent with the enterprise. Then you cut over and there is no more rollback to enterprise mode. So we have a new cluster with parallel flight loads, meaning it's synced with all the other enterprise clusters for loading only. Vertica notify us that libHDFS protocol will be deprecated in version 11. Challenge accepted again. So we are not waiting again, we are planning. We need to refactor our code to support WebHDFS protocol. Vertica R&D done a great job in a way that WebHDFS protocol emulate libHDFS. The only thing that client needs to do is just to modify the prefix from HDFS to WebHDFS, but it requires to benchmark the performance of WebHDFS comparing to libHDFS and the availability. Of course, issues were found and fixed, but two major optimizations were done. First, active name node caching. Vertica now is caching the active name node, so it reducing the number of calls to HDFS. Before the optimization, for any single call to write data or to read data, Vertica send requests to the name nodes to understand who is the active one. Now it's caching, reducing many calls and latency, of course. Second optimizations, timeout operations were set only in seconds, and now they are supporting milliseconds. Okay, so now we have Eon on HDFS with loading with WebHDFS protocol. Everything is good, the time of loading is great, but we observe many reads from communal storage. Why? We have a huge depot. Is it a bug? Is it something that we care about? It impacting us in any way? This was the first time we understand that and learned that Eon Mode is not equal to enterprise. Data transfer protocol is different. Most of our dimension tables are unsegmented. Now, in enterprise mode, when initiator writes data, data is written in parallel to all nodes. In Vertica, by default, this is not the case. In Vertica, by default, the initiator writes to his local depot, flash to communal storage, transaction ends. Now, when another request reaching different initiator nodes, his depot is not up to date, fetch from communal storage happens, this is the root cause. Okay. Investigation shows that there is a knob used peer-to-peer transfer that control the behavior. We play with it, but we decide to roll back. Why? Because now Vertica writing the data after the communal storage and spreading the data to all nodes to have the depot up to date. but it's not in parallel or like the enterprise. So the latency comparing to enterprise is higher. So we prefer to roll back and to stay with the default behavior. But we've done a measure optimization by pinning the dimension table into depot. So when node is going down and restarting, it's improving query performance because Vertica starting, loading, fetching data from communal storage, and then serving requests. Later on, another issue between enterprise and Eon, we observed that merge command is working for some dimension table very slow comparing to enterprise, few seconds in enterprise mode comparing to few minutes. Why? We analyzed execution plan and we immediately saw the difference. Of course, Vertica R&D immediately fixed that, and you can see the huge drop in performance time, and we are glad about it. So, since January this year, finally, we are live in Eon on production, not only for data ingest, but also for data processing, moving some aggregation services into Eon, finally. We continuously upgrading Vertica versions, not only for bug fixes, but also for features we care about, like complex type and of course the new operator for Kubernetes. Recently, on May, we observed performance degradation for data processing queries, not for loading data, but for data processing queries when node is down. So in enterprise mode, you have the body projection, the body node. When node comes down, the other node takes the workload. CPU and load average will increase, which is expected. In Eon mode, it's the same. When node goes down, another node is subscribed to the shards, taking the workload, but at that time, our cluster became unresponsive for data processing. Data loading continued to work without any issues, only the data processing, because they are massively consume CPU and memory, they suffer, so we needed to move them to enterprise cluster. Investigation again found the magical node that controlled that, and now you can see that when node goes down, the load average still high, which is fine, but cluster is responsive. Now we are working on resilience of HDFS, leveraging HDFS snapshot capabilities. Oleg again here is working and developing this process. So we have the main HDFS cluster. We are taking snapshots at the moment every 1 hour and shipping them to a backup HDFS cluster. What next? We are planning to simulate revive from the backup HDFS. So just remember, we are copying snapshot. It meaning if we revive from snapshot, we revive back in time. We have data loss. We need our services to support catch-ups. Something that we are working and will be finished soon. Then we plan to converge all the backend clusters to Eon. Later on, to converge all the 3 front-end clusters to Eon. Now, front-end clusters are different in a sense that most of the projections, not only the dimensions ones, most of them are unsegmented. Why? First, to allow higher concurrency in Vertica, and second, faster execution time for most, not for all, but for most of the ad hoc queries, because the front-end serving dashboard system, and they are aggregating small amount of data, period of 3 months, 6 months, that's it. Once we will converge the back end and the front end, we can start maybe celebrating. Now I'm going back to the future, where we want, what we want to achieve. We want to achieve again with Eon. We want to achieve having a primary subcluster for data ingest only. So we can modify if at the moment the nodes contains 40 servers, we maybe can build a smaller primary if it's just loading data. Then we want to have many subclusters for data aggregation. This is a massive aggregations, they need more compute. And of course, leveraging Vertica operator on Kubernetes and have many secondary subclusters, all working with HDFS as communal storage. What we can learn from the process. First, Vertica is great, and Vertica in Eon mode is really great for us. Second, Eon is not equal to enterprise, some differences. Depot is great, optimize it if you are using Eon. 3 advices I can share with you and give you is, first, benchmark real workload, not a sample, but real workload. Second, optimize. And third, simulate all the node activities, both sides of communal storage and Vertica. Thank you.